Markov process. So what is Markov process? Everything, let us go through this with an example here. Look at this example. You guys have a read first before I read for you. Take a look at this. Okay, suppose we are interested in analyzing market share and customer loyalty for Murphy's Food Liner and Ashley's Supermarket, the only two grocery store in the small town. So there is a small town. Let's say the town is like this, and there are people here. There is only two supermarket. One is Murphy's, one is Ashley's. Okay. So what we are going to find now is, in long term, which supermarket will have a strong influence on the people there, which means which supermarket is people's favorite supermarket, which one has higher market share. Okay, that's what we're going to find. I suppose in Pari Raja now is you have how much? Maybe Tesco, and then how much you have Tesco? What was that? Velvet, and there's another one I can't recall. Start with the one with Mary Brown. There's another one. I don't know the name. 3. Target, yeah, Target, Tesco, Velvet. I think these are the 3 supermarket in Pari Raja now, and which are most popular. So something like this. Maybe now for the now we can see that I think Tesco is much more popular compared to Velvet and Target. So this Tesco is now having a higher market share compared to Target and Velvet. So here for the time being we know Tesco is good, but in long term, in future, we won't know. So this kind of situation we're going to see in this example. This example, there's only 2 supermarket, which is Murphy's and Ashley's, and in long term, now maybe we don't know what is the maybe half, who knows. Okay, but in future, in long term, which one will hold the dominant market share, which one will be more popular? That's what we want to see. Okay, so to see this kind of market share in future, we use a technique known as Markov process. Okay, for us to use Markov process, we need some information. and that information is in terms of probability. Okay, now look at the second paragraph. We find that all customers who shop at Murphy's in a given week. Okay, if I read like this, of course maybe most of you are confused, don't know what's going on. So let me put it in a table. M A. I would like to, okay. M is Murphy's, Ashley's, Murphy's, Ashley's. Okay, now if I put a table like this, I will write here next week. This is this week or current week. I put here this week, this week, or you can also write current week. Alright, now we find that second paragraph, we find that all customers who shop at Murphy's in a given week, okay, this week they shop at Murphy's in a given week, 90%, which means probability is 0.9, shop at Murphy's in the following week, the next week. So the Murphy's will go to Murphy's again. That would be 0.9. The following, while 10% switch to Ashley's. So those who are shop this week, they shop at Murphy's, only 90% go to Murphy's next week, 10% switch to Ashley's. Okay, this is probability. Third paragraph, those who are shop at Ashley's, they are going to Ashley's again is 80%, that would be 0.8, and the rest, which is 20%, switch to, sorry, this one is here, Ashley's, and 20% switch to Murphy's. So this is how you have to read and see these figures in table. And this is known as transition matrix or transition table. I just, for the time being, I just leave it here as transition probability. So we need this information in terms of probability. How many of them are going back to the same place? How many of them are going back to the next different place? So these are some what you call market research they have done, and these are the probability they come out from the research. Okay, so we need this for us to predict in future. It can be, the future can be 1 week, 2 week, 100 week, many years. Okay, so like that. Now for us to do our mathematical computation, we need to give some notation. We need to give some notation. First of all, some definition, notation. Of course, before notation, we some terms. These Murphy's and Ashley's, of course, two supermarket, but the general term for it is a state. Okay, this is known as state. Maybe we can call this state 1, state 2. Okay, and we will denote this by the letter, the symbol of for pi 1, and this is pi 2. Okay. Now if you look at this, if you look at this diagram, let me explain what happened in this diagram. So a customer now, you guys want to copy this? I give you some time, copy first. So state 1 is Murphy's, state 2 is A, Ashley's, or pi 1 is M, pi 2 is A. Just think like that. All right, now let us look at this. Now we want to see, let us start from here. Now in a given week, a customer shop at Murphy's. Okay, customer shop at Murphy's, and we will write this as week 0. Okay, now after current week is week 0, we put week 0. He shop at Murphy's. What is the probability that he goes to Murphy's, and what is the probability he goes to Ashley's? According to the table here, the probability he or she go to Murphy's is 0.9. So right here 0.9. Ashley's should be 0.1, and this would be week 1. In week 2, the tree diagram looks like this. This is now, if you look at this, the customer week 0, initially he or she was shopping at Murphy's. Week 1, you can see the probability he might go to Murphy's and Ashley's. Week 2 also, he or she can go to Murphy's or Ashley's. Now, what is the probability that in week 2 a guy or girl end up at Murphy's and Ashley's, okay, in week 2? So how to compute this? I suppose you guys should know this because we have done this in statistics. You just multiply this here, write it here. So that would give you 0.9, you will get 0.81, sorry. And then next branch, you will write here 0.9, 0.1, answer is 0.09. Ashley's to Murphy. Sorry, I did a mistake here. This is not 0.9. Ashley's to Murphy's is 0.2. I did a mistake. Sorry. And this one is 0.8. Okay. Now this is 0.02. And this is 0.1 multiplied by 0.8. 0.08. Okay. This is how we have to see the probability of a person end up at Murphy's and Murphy's and Ashley's and Ashley's. Okay, these are the probability. Now, first week he end up at Murphy's. The probability is this one. Okay, first week he end up at, the probability that first week he end up at Murphy's is 0.9. First week he end up at Ashley's is 0.1. Remember, the customer is from Murphy's, from Murphy's to Murphy's, Murphy's to Ashley's, which means previously I have given a symbol for Murphy's is pi 1, for Ashley's is pi 2, and the period means the time. Murphy's week 1, the probability the customer end up in Ashley's week 1 is like this, the notation. Okay, the notation. Copy this first. For us to compute the probability of Murphy's at week 2 is, where's Murphy's? This one and this one. Take this one plus with this one. This we have done in statistics. Just recall back. The same ideology. That is Murphy's. Okay, what is the probability that a customer will end up at Murphy's in week 2 is 0.83. What is the probability a customer will end up at Ashley's in week 2? 0.09 plus 0.08. That would be 0.17. That is the answer if the question asks. Now, remember this. A customer now, how we did this? A customer from Murphy's. Okay, the customer is actually the current customer of Murphy's, and then we analyze all these things. Now I give you some time. Okay, I give you some time. Once you copy this, do the same thing, but you start with a customer from Ashley. Do like this, and do same kind of analysis what I have done here. You try first before I give you the answer. You try. Okay, what you have to do now, Now instead of Murphy's, you don't take Murphy's, you start with Ashley's. Do the same computation what I did here and see what happened. Alright, I suppose most of you have tried. Anybody have chat with me? Okay. So A to M is 0.2, A to A is 0.8, M to M is 0.9, M to A is 0.1, A to M is 2, this is 0.8. So here this would be 0.8, 0.02, 0.16 and 0.64. So if you want to find a customer end up in state 1, state 1 is what? Murphy's. Customer end up at Murphy's as second week is 0.18 plus 0.16. People end up at Ashley's in the second week, that will be 0.02 and 0.64. That would be the answer after 2 weeks, the probability after 2 weeks where this fellow will end up. Okay, this is, you can do this kind of tree diagram if I ask you to find in the second week, third week, something like that. Okay, maybe until third week. Okay, fourth week the tree is getting bigger and bigger. Now if this kind of method you can use for short future, first week, second week, next first week, next second week, something like that. Now there's another method for us to find the probability. Okay, there's another method. This is a short future probability in second week. Okay, in second week. Okay, if third week, then you will draw another branch here, third week, and then do the same thing. But what if the question asks in long term duration, maybe after 100 week or 1000 week, in long term, what would be the probability of what is the probability a guy end up in Ashley's, and what is the probability a person end up in Murphy's? Okay, in long weeks, and that is known as that probability after a long week. This one is after 2 weeks, is it? 2 weeks after a long period. Okay, after a long period, 1000, 100, maybe 200, 2000, 20,000 weeks. Okay, that probability has a special name known as steady state probability. Okay, steady state probability means after a long time where a person will end up. Okay, in fact that is the market share. Actually, we will do this now. Copy this, we will do in the next page. So we have seen after 2 weeks where the person, what is the probability a person end up at Murphy's and Ashley's. Now we're going to see, regardless of time, okay, as long as it is a long time, okay, it is a very long time in future, where a person, what is the probability a person will end up at Murphy's or Ashley's for a long time, after a long time, and that probability is known as steady state probability. Okay. I'm going for next page. We are going to find hope my spelling are correct. We know that pi 1 is Murphy's, pi 2 is Ashley's. So I'm writing this in matrix form now. Okay, this is the method, one method where we use, this is called Markov process. This is how we use. Okay, this is the formula or method. Just follow this. So you have two state, write the two state here, and copy back the two state here. This is known as transition. How to spell transition? Transition matrix. Okay, where I get this transition matrix? From the table, from the transition table here. You see this one 0.9, 0.2, 0.1, 0.8. Copy here. Now once you copy, all we have to find is what is the value for pi 1 and pi 2 by using the matrix computation. Okay, so let us do this now. If I multiply these two matrix, I will get, if you don't know how to multiply, please recall our maths. Okay. If you multiply, you will get this, and naturally you can see that this is equal to this, and this is equal to this, okay, according to our matrix property. Now take out these numbers or symbols, whatever, write it as a equation. Pi 1 equal to 0.9, pi 1, 0.2, pi 2. These are the two equations you get from this matrix, and remember that total probability must be 1, therefore pi 1 plus pi 2 is 1. Pi 1, pi 2 is actually a probability, that's all. Okay? Don't get confused. So you have 1, 2, 3 equation. I'm going a little bit down from 3. I find first this one, or you can also write like this. Okay, let me see this. Okay, let me do one first. So pi 2 is equal to 1 minus pi 1. Replace in 1. So when you replace inside the 1, inside the equation 1, you will get like this. Copy first this one. Well, try to understand. When you copy, just try to understand what I'm doing here. Okay, so you can find the pi 1. The pi 1 is actually the Murphy's. Okay, the probability a guy will end up at Murphy's is, this is 2 over 3, and this is basically, how much is this? You can leave in fraction or you can leave in a percentage. pi 1 we have computed. Now we are moving to pi 2. Pi 2 is, I'm doing here, okay, this is actually pi 2, okay, I'm writing here. Pi 2 is 1 minus pi 1, that is 2 over 3. This is 33.33. So a probability that the probability that a person in long time will end up at Murphy's is 2 over 3, and for Ashley is 1 over 3. In other words, the market share for Murphy's is 66.67 percentage, and Ashley's is 33.33 percentage, 33 percentage. Okay, which means Murphy's have dominate the market in that small town. So more people will go for Murphy's compared to Ashley's. The explanation also will be given here. Okay, you can see here. That's how we get. Markov process model tells us that in the long run, after long term, the steady state probability are 2 over 3 and 1 over 3. Of course, this is, let me reiterate that, this is Murphy, this is Ashley. Thus, this is just a simple example, the second one. If there are 1,000 customers in the town, okay, there are 1,000 people, 667 customers will go to Murphy's, 333 customers will go to Ashley's, and the steady state probability is actually your market share for the two stores. Okay, so if the question asks to calculate market share, this is how you have to find, or if the question asks to calculate steady state probability, this is the same process how you're going to find. Okay, let us do exercise 1. Maybe after exercise 1 we can have a break. Read this and try to, the answer is given there, but how to get these answers, read this first. I'll do with you together. Okay, if you read this, it's something to do with computer running or down. First question, you can see the table. Current, this is current. What is the time period here? Time period is hours. So this one is current hour. This is next hour. Question A, if the system is initially running here, what is the probability of the system being down in the next hours? The next hour it is down is, take from the table, 0.10. That is very easy. I purposely give you this so that you can understand. Now for B is the major computation. For you to do B exercise, we define the first state as running. The second state is down. In the long term, with this probability, what is the probability a computer will run? What is the probability a computer will be down? So we use Markov process. this is the answer for the question exercise 1. Exercise 2 you can try on your own. Exercise 3 also you can try. Go for exercise 4. Try exercise 4, I will show you, and then we can finish the class. Try do exercise 4. So when you read this, you can see the probability of no traffic delay in one period given no traffic delay in the preceding period, no traffic delay to no traffic delay, the probability is 0.85, that is here. No delay, no delay. Okay, no traffic delay, no traffic delay, the probability is 0.85. So this one, and the probability of finding a traffic delay in one period given a delay in the preceding period is this one. Okay, delay, delay, 0.75, delay 0.75. Okay, that's how you do. Now if you are given 0.75 here, how to find this? This would be 1 minus 0.75, because if you notice the transition table, if you plus the row, you will get 1. Okay, the answer is 1. Now if you are given 0.85, then this one would be 1 minus 0.85. That's how you find the transition period, the transition matrix for probability for all the states. So this is the answer for A, transition probabilities. Now once you have probabilities, you can answer the next question. Assume that the motorist entering a traffic system and received a report on a traffic delay. What is the probability for the next 60 minutes? 60 minutes is 2 time period, 2 periods, which means you see the period is considered 30 minutes only. This is one period, like 1 week. Okay, 30 minutes. What is the probability that for the next 60 minutes the system will be in delay state? Okay, there are 2 states now. First state let us define as delay. Second state is no delay. Let us do, this is for 30 minutes is 1 period, 60 minutes is 2 periods, so we can do tree diagram here. This is 0, this is 30 minutes, this is 60 minutes. Delay to delay 0.75. They want what is the probability that the state will be in delay state. So we only want this one, multiply this, you get 0.5625. So the first stage is delay on the second period, which is 60 minutes. This is the answer, 0.6.